And again, welcome. Tuesday night, April 2nd. This is our Unit 2 review. It's our Unit 2 exam review, and it's week 11. So welcome. And what I have is, if you go back to, let's see, if you go into your course in, let me back it all the way up so you can see where I got this. So if you go to Module 6, which is where we are, has exam 2 and then sections 13 and 14. If you go to the learning activities, I put in there a practice exam, like a paper practice exam, and then the key for it also. Now that's not what your grade is in this section. Your grade is this one here, the review that you have to do online. Okay, you click the link and it takes you there. But what I want to do is answer some questions from this practice exam, since we all have a copy of that and it's the same for everybody, because your online review is different for each person. The questions are different. So what I want to do is just go through here. Let me see how many questions it is real quick. Looks like 20 questions, plenty of time. But I want to know what you guys have questions about. So yeah, if you haven't scheduled your exam, you better do that like right away. Okay. And the exam is due by next Saturday, the 13th. Okay. So if your testing center isn't open on Saturday, make sure that you do it before that day. And then if you are not going to be at a testing center, you need to let me know, because I don't have it loaded in ProctorU at this point in time. So if you're going to do it through ProctorU, you need to let me know through an email as soon as possible. Okay, so we're looking at this. Oh, and by the way, let me just make a note of what's coming due here, okay? So today's the 2nd. We have the project is due next Saturday the 13th, and whatever homework you have due next Saturday the 13th. The review quiz, you should do that before you take your exam, right? That would be the smart thing to do. And then any other Unit 2 material that you haven't turned in is due by that date. So to schedule your test, you have to go to the Ivy Tech website. Let me try and show you that here. I think you can just do it from the Ivy Tech website. I haven't scheduled a test through Ivy Tech in a long time, right? I don't think I ever have. So let's see if we have this. Can someone direct me real quick here? So if you go to My Ivy, you can do it. I don't see the menu how it used to be here. I haven't been on this website in a little while. You might be able to do it from your campus too, I'm not sure. There we go, type in testing center and we have testing services. There we are, right there. And then click on schedule now. How easy was that? Does that make sense? So I just went to ivytech.edu and then I just typed in whatever I typed in there, testing center, and then this came up, and just click on schedule now and it'll take you up to the, okay. Or if you log into My Ivy, it should be readily available. My Ivy is different than yours, so it won't make sense if I log in. But log into your My Ivy and you should have a little tab that says testing services. All right, so here is the paper practice exam. Are there any other questions? Yeah, okay. So the best one would be go to My IV, and then in the drop-down menu, you should have the testing center schedule an exam as a drop-down. Okay? All right. So on this paper one, and of course you all have access to this, but I don't want to do every problem if we don't have to. I just want you to look at the problems and say, hey, do you need help with this? Do you need help finding the absolute change or the relative change? So the absolute change, remember, is the new minus the old. So in this case, it's going to be the 5223 minus the 4948. And then the relative change, what would be the relative change? How would we figure that out? Yeah, it's going to be this answer up here. Let's see what that is. 52.75. What is that? $2.75 maybe. So we would take that answer and divide it by the original value, the old value, so the 49.48. Now, when you get this relative change, it's going to be a decimal. And then you can make that a percent, 5.56%. And it looks like it was an increase, right? So you could write a sentence saying, the price of Easter dinner has increased by 5.56% from 2013 to 2014. That could be our sentence. So look at number 2 and 3 and see if you have a question about either of those. Do you want to see either 2 or 3? Pamela, which one or both? Okay, so if we do number 2, now this one leaves it open as to which one is the new and which one is the old. So I'm going to say Parkview is the new, Lutheran is the old. Okay, so I'm going to do 7660 minus 5142, and then let's see what that is. Help me out, how much is that? 2518. All right, so that's 2518. And then we're using a relative change statement, so we're going to have to do 2518 divided by the old value, right? New minus old divided by old, so 5142. And then when we do that, we get 0.49, so 49%. And then the statement we could make is that Parkview Hospital has 49% more patients than Lutheran Hospital. Now, if we did it the other way, if we did Lutheran as the new, we'd be subtracting like this. And then we would be getting a different percent. We'd do negative 2518 divided by the Parkview number, 7660. And we would get negative 0.329, which is negative 32.9%. And now this statement would have to be different. So the first one, the 49%, would be Parkview has 49% more patients than Lutheran. This would be Lutheran has 32.9% fewer patients than Parkview. Notice how the percentages are different because, remember, we're dividing by a different number here. So the next one, we would separate proportion. Well, there's a couple ways we could do this. We could do new equals 1 plus the percent as a decimal times the old. That would be one way to do it. And then the other way would do it would be to separate proportion, where we'd say 2675 and then the sales tax is 7%, so that is the bill after tax. That would be 107%. And then on the bottom, we'd have X. We're trying to figure out what 100% is. And then we'd have the 100 over here. Then you've multiplied 26.75 times 100 and then divide by 107. If we were doing it in the equation form, we'd say the new is at 2675. And then we'd have 1 plus 0.07 times the old. We're trying to find out the old value. Whoops. And so we'd have to take 2675 and divide it by 1.07. And it looks like if we do this, the old is $25. All right, so I need to check my attendance really quick. We got somebody not marked. It should be marked. And let's see who that is. All right, all taken care of. So how about number 4 or 5? These are the same type of question. So do we need to see either 4 or 5? So for number 4, the new amount is that 5,800. And the old amount, we'd have 1 minus 0.107, right? Because it was down 10.7% times the old. So we have to divide by, we take 5,800 divided by 0.893. And there's more students in 2011 because the 2012 enrollment is down. So that's how we know we needed to have more students in 2011. So same idea with number 5. The original price was $249. We're going to find the new price this time. So it's 1 minus 0.2 times $249. So the new price is marked down from the old. So the new price is 0.8 times 249. So there's another way we could do number 5. And that would be saying the original price was $249. That's the same as 100%. The new price we don't know, but the new price is 80% because it's marked down 20%. And either way we do this, we're going to get $199.20. Okay. And answer number 4 is at $64.95. Number 4 is $64.95. Yep. All right. So how about number 6? Actually, why don't you guys take a minute to do number 6 and put your hand in the, raise your hand. Oh, this one, let's just talk about this for a minute. So remember, we talked about this already. It says they're going to give everybody a 10% pay cut and then a promise of a 10% increase. explain quantitatively why this is or is not a good deal for the employees. Can someone do that for us? You can unmute yourself if you want.
Hi, this is Kendra.
Great.
How of a statement are you going to be looking for in something like this? Because like a simplified statement would be 10% of a lesser amount will be less than 10% of a higher amount.
Yeah, so you want to give a little bit more
But
than that.
how, like,
So
okay.
like so like Kelsey wrote 10% of 100 is 10, but 10% of 90 is 9. So you have to give a little bit more than that. Actually, the two answers together would be great. So you could say, well, if I make $100 and I'm going to get 10% pay cut, that's going to be $10 I'm going to lose. So I'm going to make $90. Now I'm going to get a 10% raise on my $90. Well, that's only $9. So I'm going to be up to $99 and not back up to my original 100. So you want to give the explanation, but give some meat behind it, which would be the numbers. Does that help? All right. So number 7, I want to go through this one because I think there's a little bit of a struggle on some of your guys' answers when I was looking through your work. So this one here has a trend line, and the equation's given 178.09x minus 353,194. Notice that 353,194, notice that this number right here is not the same as this one down here. It's not the y-intercept. So that tells us right away that we're going to put the actual year in when we do our calculations. Notice how the ordered pair is 2004, 2855. That means that you had to put 2004 in for the x, not the number of years since 1992. So if this number here matched the one down here, like down here, wherever that point is, then you would be using the number since that first one. All right. So it says estimate the enrollment for 2004. So that's where we would take this and we would put in, we'd say y equals 178.09 times 2004 minus that 353,194. And then we would get our answer, about 3,698 students. So we get the 0.36 on the end, but we know we can't have 0.36 of a student, so we're going to round to the nearest student. So our final answer would be 3,698 students. And then it says, how does it compare to the actual value? Well, the actual value was 2855, so it's greater than, and you could say it's more than by, let's see, what we got, 3698 minus 2855. It looks like a lot. I don't know how many that is. 2004. Oh, 3698 minus, what is that? 843. Thanks in the chat box. You guys are awesome. So we could say the actual value is 843 students less than the model. So it says interpret the meaning of the slope and the trend line. So when you guys did this, some of you put, when you interpreted the meaning of the slope, you said, well, the slope is the rise over the run, or it's the change in the y or the change in the x. But that's not what this is asking. This is asking for the meaning of this slope in particular, the 178.09. So the meaning of that slope is that the enrollment increases by 178 students approximately each year from 1992 to 2010. So we'd say the slope increases approximately, what was it, 178 students, not the slope, I'm sorry, the enrollment, because that's what we're talking about here. The enrollment increases approximately 178 students each year, and this is on average, right, because it's not the same every year, from 1992 to 2010. So that's the meaning of the slope of that trend line. So then it wants us to classify this correlation as weak, moderate, or strong. And so when we look at this, it's pretty moderate. I mean, it's not super strong because you got this big dip right in here. So, you know, the big dip between 2004 and 2007, it looks like. So we could say it's a moderate positive correlation. So that's how we would describe the correlation. It's moderate because the dots are pretty close, but they're not super close. And then we'd say it's positive because it's increasing. So those two pieces, moderate, positive. And you'd want to, you know, describe this a little bit better. I'm just giving you the bare bones here. You'd probably miss a half a point on that. Okay. We want to more correctly say something like there is, you know, write it in a sentence. Okay. And it says, should we use this model to predict headcounts for 2020? Well, this model is only good for 2010, you know, up to 2010. And so you'd have to say no. And this was another question that some of you guys missed. The answer is no. And it's because the year 2020 is outside the scope of the model. That's the reason right there. 2020 is outside the scope of the model. We don't know what happens after 2010. So number 8 asks us to write an equation, and this is a linear model. So that means it's going to be a y equals mx plus b, right? And the y and the x stay the same. The m and the b is what we're concerned with. So the m is the rate of change and the b is the starting amount. So which of these is the rate of change, the $10 fee or the $4.25 per soda? Yeah, whenever you see per, that's telling you that that's the rate. So 425x plus 10, that would be our linear model. What do the variables represent? The x represents the number of sodas, right? Because it's per soda. And the y represents the total cost. The independent variable is the sodas, and the dependent is the total cost. It's dependent because it depends on how many sodas you purchase. And then how much soda could you drink for $25? Well, let's see. One soda is $14.25, right? Because it's $10 plus the $4.25. Two sodas is $4.25 more than that, so it's going to be $18.50. Three sodas is going to be $22.75. And four sodas is going to be more than $25. So it looks like you can buy 3 sodas. And that's just one way to do that. There's other ways. So number 9 is a little bit different, and I'll show you the difference here. And then I'm not going to do part B or C unless you really need me to. So part A says find the average rate of change. So we have this is the Y, this is the X. So the X is usually the year. So Megan, yes, you can do that, and then you would have to subtract and divide to solve that equation. Yes, you could do it by solving the equation. Yes, just like that, Kendra. And you're going to get a decimal, and you have to round it down because you can't purchase 0.5 of a drink. All right, so yep, that's a good way to do it too, in the chat box there. So on this one, we're going to take the new minus the old, so 5209 minus the 3210, and we're going to take that and we're going to divide it by 2010 minus 2000. So we're going to do, looks like 209, 1999 divided by 10. 199.9. That looks like the rate of change, so approximately 200. So setting up a linear model, again, that's going to be y equals, and then 1999.9x, and then plus whatever the starting amount was. Oops, let's see, the starting amount was the first year, 2000, 3210. Whoops, I need to put a plus sign in there. And then we would have to state that x equals 0 represents the year 20 or 2000. So then x, if you were putting values in, you'd be putting in the number of years since 2000. So for part C, we would do y equals 1999.9 times 13, the number of years since 2000, plus 3210. Number 10, same idea, the linear model, y equals the rate of change. You're selling them for $200. Oh, I guess let's see. Set a linear model that calculates your profit or loss for a given number of sales. So 200 times the number of alpacas. And then what are we going to do with that 10,000? It says you spend 2,000 and you're gaining the $200. So is the total that you have the 200 times the alpacas plus the $10,000? Or is the total that you have 200 times the number of alpacas minus the $10,000? It is, it's subtracting, yeah. So this starting amount is a loss. The alpacas times $200 is a gain. And so it wants us to find the number for 24 alpacas. We're just going to throw a 24 in for the x. And then whatever we get there. Thank you, Megan. Negative $5,200. So you have a loss of $5,200. And it says, how many do you have to sell to break even? We want to know, when does 200x equal that $10,000? When will the y be 0? That's what we're really asked. So 10,000 divided by 200, it's probably 500? 50 probably, I don't know. 50, yeah. 50 alpacas. All right, we have to move along a little quicker. So number 11 asks us to find the absolute and relative change. And so the absolute change, just remember, I'll show you one. It's subtracting the new minus the old. And then that one is taking your answer divided by the old. Okay, that's how we do these for this table. And so if we do this, we would get 0.65 along here, And I want you to remember that when the relative change stays the same, we don't have a linear model, we have an exponential model. Since the relative change stays the same. And then it wants us to write an equation. And so the equation, let's see, the equation, if you remember, is the amount, or A or Y, whichever you want to use, is going to be the starting amount. So the starting amount was 21.7 times, and it's 1 plus the rate of change. So 1 plus 0.65, or 1.65. And then it's to the t power, or the x power. It's the time power. These are minutes. So there's the model. And then it wants us to predict the area of bacteria after 8 minutes. So we're going to say the area is 21.7 times 1.65 to the 8th power. And that'll give us the area. And let's see what the area is measured in here. Let me just scroll up for a second. It is square millimeters. So whatever we get, we're going to get square millimeters. 1192.15. All right, thanks, Kelsey. And this would be square millimeters. And then this says the Petri dish is 3,000 square millimeters. How many minutes? So what we could do is we could throw a 9 in here and see what we get. Did we get more than 3,000 or not? And the answer is no. And then if we put a 10 in, we get more than 3,000. So that means it would be between 9 and 10 minutes. So that's the only way we have to do this in this particular course. Just put numbers in for the power right here and see when it goes past 3,000. Number 12, Professor Ivy starts with 100 followers. Oops, sorry about this. What's going on here? Oh, there we go. That's better. All right, so Professor Ivy starts with 100 followers. It doubles every month. Well, if it doubles every month, that tells us about the growth factor. So the growth factor is 1 plus the percent change. And since it's doubling, it's just 2. It's 100% change. So there's the model. And then how many followers after 4 months? We're just going to throw a 4 in right there for the t. And we actually don't even need a calculator for this, because it's going to be 100 times 2 to the 4th power. And 2 to the 4th power means 2 times 2 times 2 times 2. So let's see. That looks like 16, so it's 100 times 16, so 1,600. All right. How many months would it take to reach 1,000,000? So all we're going to do is we're going to change that number until our answer is greater than 1,000,000. And then and it might be around 13 months probably. So between, it ends up being between, 13 isn't enough. Whoops, oh my gosh. Fat fingers. Not really. All right, any questions so far? I know I'm going through these a little bit quick, but you have access to this, to the answer key, okay? I mean, this is the explanation that goes with the answer key, but you have access to the answer key if you need it. And this one, same idea. I'll just write the equation here. A equals the cell phone weighed 2.5 pounds, and then it's decreasing by 9%, so it's 0.91 to the t power. Number 14, that's going to be 6,000 times, it's increasing, so it's going to be times 1.09 to the t power. And then let's look at number 15. So this one is the credit card one, so we're going to do $300 times, it wants to know how much the interest is going to be. So if you remember, the interest equals the principal times the rate times the time. So the principal is 300, the rate is 0.1899 divided by 12 because it's the monthly rate times the time. And then I guess, let's see, 1 month, so 1, since this is monthly, 0.1899 times 300 divided by 12 is $4.75. Perfect. So it would be the monthly interest. So it's just 300 times 0.1899 divided by 12. That would be the month's interest. All right. So let's look at this credit card. And we'll have to do this without Excel. I'm just going to show you what we do if you remember. 300, the finance charge is 15%, so it's going to be 0.15 divided by 12 times 300, and that's $3.75. Actually, let me put it in here. 300 times 0.15 divided by 12, $3.75, and then the new balance is going to be the 300 plus 3.75, and then the minimum payment is going to be 2% of that, so it's going to be 303.75 times 0.02, which is $6.08. And then the carryover balance is going to be 303.75 minus the payment, 608. All right, and we continue that pattern. Number 17, and I'll go back to that and finish it if we have time. Number 17, your wealthy grandmother deposited $1,000 in a savings account, earning 4%, and you can have the money when you graduate in 2 years. How much money will you receive if the interest is compounded annually? So again, on the back of your formula sheet, it has the balance. So the annual one is going to be the one where it says balance equals principal times 1 plus the rate to the time power. If it's not annual, if it's monthly or weekly, it's going to be the one below that that has the number of compoundings each year in the formula. So the balance here is going to be the $1,000 times 1 plus the rate. So 0.04, remember those rates are always as a decimal in these. And then to the time power to the 2 power. So you have to run that in your calculator, see what you come up with. Go ahead. Throw that in your calculator. All right, so $1,081.60. Oh, something I need to make sure you guys are aware of. So when you guys have done your Excel spreadsheets and things, and you're dealing with dollars, you need to make sure you format your spreadsheet for dollars. Like some of you in your Excel that you turned in, you were doing your credit card thing, and let's say you had $1,227, and then you put like all these decimals in there. You need to change it so that it's dollars, and it only goes to, you take all those off, you'd make that a 6 be a 7. So you need to change it in Excel and format it so that it gives you the rounded dollars. So like here, so see how mine are all rounded to the dollars, and that's just, you just press that button right there and it gives you the dollars. Okay. And it says how much we receive if the interest is compounded monthly. So now the formula is going to be a little bit different. And that formula is going to be balance equals 1,000. And now we're going to do the other formula, 1 plus, and then the interest, 0.04 divided by the number of times it's compounded in a year, so divided by 12. And it's, the 1 isn't in there, it's just 0.04 divided by 12. And it's 1 plus that. And that's to the, let's see, it's going to be 12 times 2. So it's the number of times goes in 2 spots on that formula. And 1083.14, thank you, Kelsey. And then C, it changes the 12 to a 365. And then that's going to be up in the power also, 365 times 2 years. And you can see, remember that the more compoundings there are, the more interest you earn or owe, whichever it is. All right, number 18. The 30-year mortgage, what would you type into Excel? Somebody type that into the chat box. 30 years, $125,000 loan at 4.5%. What would you type into Excel to find the payment? So you all should be putting your answer in the chat box on this one. So yeah, we're going to do 0.045 divided by 12, comma, and we can either do 360 or we can do 12 times 30 or 30 times 12, and then negative 125,000. And you want to make sure you have the equal sign there because it won't work in Excel if the equal sign isn't in there. Well, it's just a given that your mortgage payment is going to be a monthly payment. You're finding out the monthly payment, basically. That's what Excel calculates for you. I mean, if you put a different number in here, like if you put 52 in there, you get a weekly payment, right? But a mortgage generally is paid monthly. So we're just going to, whenever we're talking about mortgages, it's going to be monthly unless it says otherwise. So let's see how much will be paid. So how much will be paid over the life of the mortgage? So if the payment is 633.36, how much will be paid out over the life of the loan? Well, times 12 months times 30 years, right? And this would be how much we paid all together. And then let's see what that ends up being. That is 60 cents on there. So $228,000. So they're borrowing $125,000 and paying $228,000. How much would be paid in interest? All you have to do is subtract those. Okay. And finishing up the last two. Number 19. Johnny has $750 to rent. Johnny currently pays. Why is it always Johnny? Oh my gosh. That's my name. I used to complain about that all the time. Johnny was always the example kid. Anyway, let's see. Johnny currently pays $750 in rent, but wants to spend this money to buy a house instead. He determines that monthly insurance and taxes will be $150, and he has no other debts. So if he currently pays $750 and monthly taxes are going to be $150, how much does he have to put towards his mortgage each month? How much does he have to put towards his mortgage? 600, right? Thank you, Megan. So we're going to put in the values. We're going to put in the interest rate 0.045 divided by 12, comma 12 times 30 years, comma negative 600. And that is going to give us how much Johnny could borrow. I don't have that value. I suppose we could, let's see, we'll just pop that into Excel real quick and see what it is. $118,416.70. 416.70. All right. And the last question, if I invest $100 per month in a 401k at 5.25% compounded monthly, what would I type into Excel? So now we did the PMT to find the mortgage payment. We did the PV to find the mortgage amount he could borrow. And we do FV to find the future value for a 401k. So equals FV. And then what? .0525 divided by 12. It's monthly. 12 times how many years? 20 years, comma, negative 100. So that's what we would type in, equals FV 0.0525 divided by 12, comma, 12 times 20, comma, negative 100. And then it says, if the balance is 42, 311, 18, how much interest did I gain over a 20-year investment? So what we're going to do to find out how much the interest would be is we'd have to find out how much you put in. So if you put in $100 a month times 12 months times 20 years, that's probably $24,000. And then if the balance is 42, 311, 18, we're going to take 42, 311, 8, 42, 311, 18 minus that $24,000 that you put in and get 18, 311 and 18 cents. Perfect. Thank you, Kayla. And yeah, Kendra, good job on that. Okay, so there we go. So if you want, whatever one we could fill this table in if you want. Otherwise, I can answer any additional questions you have. I'm going to shut off the recording and give you guys a chance to either exit if you need to or hang out and ask questions.